The third objective in the topic solving radical equations is to solve equations with rational exponents. So with rational exponents, the big key here is that there is a power that exists in the equation and it's a rational power, a rational exponent, meaning that it's a fraction. And so the relationship that goes between, let's say number one, the ID problem that I'm going to do in this video, right here, negative 8 plus the grouping of 4r plus 12 raised to the 2/3 equals 8. The 4r plus 12 inside that parentheses is trapped underneath that power of 2/3. And so that's the thing I'm going to eventually isolate. If you remember back to solving equations with radicals, it's the same thing, except for in this case it's not a rational exponent, it's a radical. And so I had to isolate the piece that was trapped underneath the radical, 2x minus 1, or over here, x plus 1. Similar thing, all right? They're just written in different ways, but if you remember the relationship, you can go back and forth between the two from radical to rational form. You've already done these, and so you've isolated the radicals and then continued solving step by step. Now we're going to move into isolating the rational exponents, or the bases with the rational exponents. So if you ever see a problem like number one on a test or a quiz, the big thing that you should notice first is that, oh, there's a power or an exponent there, and it's a fraction, a rational exponent. So these steps that I wrote in red are very necessary in order to successfully complete this type of problem. The first step, get the base and rational exponent by itself. This will look different for each problem. It just depends on what the problem gives you. The base might be different. In this case, if you notice in number one, the base is a grouping of terms. 4r plus 12 is the entire base. I know that to be true because they're in parentheses, and that whole parentheses is trapped underneath the radical. Remember, the base always goes with, trapped underneath the power. The base always goes with the power or exponent. In number two, I'm going to do this one as well. This time, the base is only the variable. I know that to be true because there's no parentheses around that 2m. If there was a parentheses around the 2m, then the 2 would also be part of the base, but there is not. It doesn't give me that, so eventually I'm going to have to isolate just the letter m with the power. So that's your first thought. What's the base? And I have to get that base by itself on one side or the other, depending on what side it is, all right? So the base in this case, 4r plus 12 in parentheses, is on the left side. So I need to get by itself on the left side. There's only one other thing that exists on the left side with that. It's a negative 8 being added to it. And so the opposite of a negative 8, I have to add 8 to both sides. Once I do that, I'm going to rewrite what I have left on the left side. Adding 8 to the left side cancels out the 8 there. And again, this step will look different each time, just depends on what the problem gives you. But I added 8 to cancel out the negative 8. So I'm left with just my base then, parentheses 4r plus 12 raised to the 2/3 equals 8 plus 8 is 16. So I did step one. I got the base and its rational exponent by itself. Now, for step two, it says raise the base to the reciprocal of the rational exponent. When I do this, I have to do this to each side of the equation. And this should cancel out the exponent. So what I mean by that is I'm going to, right below the steps here, you can write this if you want. I just want to show you what I mean a little bit more. I'll write it up here in the top corner. If I have a fraction, let's say it's 4 over 5, and I want to multiply it by something so that it gives me 1, I can multiply it by its reciprocal. I flip it, 5 over 4. And if I do that, 4 times 5 on the top is 20, 5 times 4 on the bottom is 20. 20 divided by 20 is 1. Or I can also just say there's a 4 on top here, 4 on bottom, 5 on top, 5 on bottom. Everything cancels out, so I'm left with 1. So that's the same thought process. This base over here is trapped underneath the power of 2 over 3. So I have to raise this base to, I'm going to put it in parentheses, I'm going to raise it to the power's reciprocal. So in this case, it's 2 over 3. I need to raise it to 3 over 2. And when I raise it, the powers multiply on each other, all right? And whatever I do to one side, I have to do to the other. So now, because this piece exists right here, I have 2/3 multiplying with a 3 over 2. Everything cancels out. The 2, the 2, the 3, and the 3. 2 on top, 2 on bottom, 3 on top, 3 on bottom. So I'm left with no power there, or a power of 1, right? But whenever there's a power of 1, I don't have to write that. And so this process that I just did and crossed out in green frees up my base now. And that's the goal of number 2, step 2, is that your base becomes free and it just becomes a linear piece. Equals 15 to 3 halves. Remember, you can put that exactly like you see it in your calculator. That equals 64. All right, so please be following along, and hopefully, as you're trying this on your calculator, you get 64 as well. Now, at this point, I've done step 2. I know that step 2 is complete because I should have no more exponents at this point. In this case, my exponents canceled out. These went away, and this math, 16 to the 3 halves, turned into 64. So at this point, I'm done with step 2, and I know I'm doing my math right because I have no more exponents. They're gone. Now, step 3 says solve the remaining equation for the variable. So again, this step might look a little bit differently, just depends on what it gives you. But the process relates back to Algebra 1. You just have to isolate the variable on whatever side it is, and then solve for it. So, the first step in that, I have to kick out the furthest thing. That 4 is closer than that 12, so I have to kick out the 12. Alright, the 12 is being added, so I have to subtract it from both sides. When I subtract it from the left side, the side of my variable, it cancels it out. So I'm left with 4r on my left side. Equals 64 minus 12 is 52. And then finally, that 4 and the r are being multiplied with each other, so I have to divide by 4. Divide by 4 on both sides. And I'm left with r equals 13. And I'm done. Alright. Step-by-step process. Please follow the steps and read exactly how I just did it. And again, be thinking I need to raise the power to the reciprocal, and at that point it should cancel out all the powers, and then I should just have a linear equation left to solve for my variable. Next example, before you try one on your own, I'm just going to go through the steps again just to show you the process. First step is to get the base and rational exponent by itself. And again, I've already discussed this. The base, this is the biggest part of this, is to identify the base and rational exponent. Again, the base is only this m. Only the m is being raised to the 3 halves. So I have to kick out everything else on the left side before I can do step 2. So step 1 again looks a little bit differently than it did in the first I do problem that I did. But first things first, the furthest thing away from the base of m, or that variable, is this 7. The 7 is being added to the 2m to the 3 halves, so I need to subtract it. I subtract it from both sides, so it cancels it out on the left side, where my variable is, and so I'm left with 2m to the 3 halves equals 1024. 1024. Then from there, I can go ahead, and this 2 and this m are multiplying on each other, so I can divide by 2 on both sides. Divide by 2. 2 divided by 2 cancels out to 1, so I'm left with m to the 3 halves equals 1024 divided by 2, which is 512. One last thing. Now, this is the end of step 1. It says to get the base and rational exponent by itself. That was a 2-step process in this case, but I did in fact do that. The base of m raised to the exponent of 3 halves is by itself, so I am done with step 1. Moving on to step 2. Raise the base to the reciprocal of the rational exponent. So I'm going to raise the base of m to the reciprocal of its exponent. In this case, the reciprocal of 3 over 2 is 2 over 3. Alright, put it in parentheses. Whatever I do to one side, I have to do to the other side. 2 over 3. So, 3 halves times 2/3, because they're both in the powers, I raised it to that side. They cancel out. 3 divided by 3 is 1. 2 divided by 2 is 1. So I'm left with just m on my left side. And 5/12 raised to the 2/3 is 64 again in this case. So, step 2, I'm done. I raised each side to the reciprocal of the exponent, and this cancels out the exponents. And in this case, I'm done with the problem. If you notice, you should have no more exponents, which I don't, and then I solve the remaining equation for the variable. In this case, the variable is already by itself, it's solved. And so I'm done. I didn't have to do step 3. So it's just another example of what this types of problems might look like, all right? Follow it step by step until finally you get the variable all by itself without a power equaling a number. So go ahead and try the you do problem on your own. Your first thought is, what is the base? In this case, the base looks to be a group of things because there's parentheses. Then after you discover that, how do I get the base by itself before I can move on to step 2? In this case, that -2 looks like it's multiplying with that base. And so you got to think, how do I get rid of multiplication? So go ahead and pause the video and try this one on your own. You could have paused the video and tried this one on your own, and I'm in the process of solving it myself. I did the first step. I circled the red number 1 up there. The -2 was being multiplied to the base of 3 minus 61a in parentheses, so I had to divide by -2. I did that on both sides, so that canceled out the -2's on the left side, and then -1250 divided by -2 is 625. Then I was left with 3 minus 61a to the 4/3 equals 625, and so I had to raise each side to the reciprocal of 4/3. That's what I did in green up here, so that's my second step I'll put. I raised each side to 3/4, which is the reciprocal of 4/3. That cancels out the powers on my left side, leaving just the base now, 3 minus 61a, and then 625 raised to the 3/4 is 125. At this process then, hopefully so far your work looks a lot like mine. I have to just solve for the variable of a. It's a linear equation. In this case, it's 3 minus 61a, so it looks a little bit different. The 3 is minusing 61, but the 3 is still positive. So in order to get rid of a positive 3, I have to subtract 3 from both sides. All right? Then that cancels out these 3's over here, and I'm left with negative, because again, this negative has to go along for the ride with the 61a, equals 125 minus 3 is 122. Then finally, -61 and a are being multiplied on each other. So I divide by -61, divide by -61, cancel it out, so a equals 122 divided by -61 is a -2. And I'm done. So, if you didn't get a equals -2 for your answer, please raise your hand and I will come check your work.